This is question 1 from practice exam 3. It shows on the question they are two long parallel wires that are separated by 3 meters. Each wire has a 28 amp current, but in opposite directions. So if you can see here, I have drawn two wires in parallel, one going in the positive, one going up, one going down with the 28 amps, and then 3 meters in between them. Then the question asks us in 3 parts to determine the magnitude of the net magnetic field at the midway point between the two wires at part B, which is 1.5 away from this wire, and then 4.5 away from that wire. So on the first, we would also be using this equation to find the magnetic field, and also the net, kind of adding them together depending on what you did. To determine which direction the magnetic fields are going on the left and the right, because depending on the current, which direction it's going, I use the right hand rule, so you get plus or minus or which direction in or out of the board. On part A, it's asking us for the midpoint right in between here, and since this is the equation, both of the r's on this section would both be 1.5, because 3 divided by 2, it's the midway point, would be 1.5, and since they're opposite each other, they're going in opposite directions, they'd be subtracted from each other. So you'd get the same value for both of your magnetic field of the left and magnetic field of the right. You'd subtract both of those, so you'd end up with a magnetic field of 0. So for A, the answer is 0. On B, it's asking on this part with the 1.5. So you use the same equation, that minus that, because you use your right hand rule to figure out that the BR, the B right, is going in the negative direction, and then you can kind of take stuff out of that, and you get, you're dealing with your R's, or your radius between everything. So right here on the B on the left, so this is the left wire, that's what I'm indicating, this dot right here is only 1.5 meters away from that. But on the right wire, you have to add 3, add 1.5 to determine your R. So that's what I did here. I did 1 over 1.5, and then 1 plus 3, which gets you, it's a 3, which gets you 6 over 9 minus 2 over 9. You can do this in decimals if that's easier. I did it in fractions. And so if you reduce everything, you get 4 over 9. And then you plug everything in using your mu, using your current that you're given, and then 2 pi times 4 over 9. And you end up with 2.5 times 10 to the negative 6 Teslas for the magnetic field at point B. Then for point C, it's the same idea, is that make sure that you have your the directions of your magnetic fields in the right direction, using your right hand rule. And anything tricky with this one? Oh yeah, so on the right side, you have 4.5 meters away from the right, but then you have to add 3, add 4.5. So you have to make sure you keep your signs correct with that. And I just did this in decimals, that was easier for me. And then I plugged everything in, and I got, for point C, the magnetic field to be 4.98 times 10 to the negative 7th Teslas. Hope that helped.